All right, if you are looking for the question 5 reteach, you are in the right place. And this one is a notoriously tricky question, so pay close attention and I will help you out. So it basically just says which of the following could represent a chemical reaction. And what it's attempting to see is if we have the right understanding as to all of the things that make up a chemical reaction. If you've just recently seen the reteach video for question number 4, then you've heard me say this, but it's very important to continue to say this, and that is that a chemical reaction, or for a chemical reaction to have occurred, a few things have to have happened. Number one, a new substance has to have formed, and that means that the atoms and molecules in the reactants had to rearrange and form new molecules on the other side. And the other thing that has to be true is that there has to be the same number of atoms in the reactants and products, and that there has to be the same type of atoms in the reactants and products. Let's go ahead and take a look at an example. All right, so here on the top of this page, I've created sort of a chemical reaction checklist, and that is, has a chemical reaction occurred? Well, we need to answer these questions first. And so if we look here in this particular reaction, what I'm showing you is a substance made of a molecule consisting of 1 white atom and 3 black atoms plus 2 white atoms bonded together to make a molecule, yield a black with 2 whites and a white with 2 blacks. And so we need to ask ourselves the following 2 questions. Number 1, are there the same number and type of atoms in the reactants and products? Well, here we go. 1, 2, 3 blacks in the reactants. 1, 2, 3 blacks in the products. 1, 2, 3 whites in the reactants. 1, 2, 3 whites in the products. Check. So did the atoms in the reactants rearrange to form new molecules in the products? Well, does this molecule here and this molecule here look anything like these 2 molecules? I think we'll find that the answer is no. And the reason is because these 2 molecules broke apart, rearranged, and formed new bonds made of different types of different formations of the same atoms. And therefore, this is a chemical reaction. Now, suppose that instead the equation looked like this, and I think you can see I'm just copying and pasting this and flipping it over to the other side. We'll take a look at this now. Let's see if it still passes the test when it's like this down here at the bottom. Well, number 1, are there the same number and type of atoms in the reactants and products? Yeah, I think so. It looks pretty good, right? I copy and pasted it. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So it looks pretty good. Well, not so fast, because did the atoms in the reactants rearrange to form new molecules in the products? Not this time. Actually, this model here actually shows that the substances were potentially going to react, but what actually happened was nothing. On the other side, we just got more of the same thing. This doesn't satisfy our chemical reaction checklist that the bonds of the molecules in the reactants must break apart, rearrange, and form new molecules in the products. So if it looks the same on both sides, that's probably not a chemical reaction. In fact, it isn't a chemical reaction.